In aqueous solutions, metal oxides can react with acids to form a salt and water. Iron-3 oxide plus 6 moles of hydrochloric acid produce 2 moles of iron-3 chloride and 3 moles of water. How many grams of iron-3 chloride will be formed when 35 grams of iron-3 oxide react with 35 grams of hydrochloric acid? From Part A, how many grams of the excess reactant remain? If the percent yield of iron-3 chloride is 92.5%, what is the actual yield in grams?
So this is your reaction, and it says how many grams of iron-3 chloride will be formed when 35 grams of iron-3 oxide reacts with 35 grams of hydrochloric acid. So first of all, we're going to be working with the limiting reactant, because that one is the one who tells you the amount of product that you can get. So what I do in the first place, I work with the molar masses of everything I care about, okay? So I want to know about the grams of iron-3 chloride, and these are the givens, which means that I'm going to be working with the molar masses of iron-3 oxide, hydrochloric acid, and iron-3 chloride. Okay, so for the molar masses, I have 2 irons and 3 oxygens. I add them, and I got 159.69 for hydrochloric acid, 1 hydrogen and 1 chlorine, which gives me 36.45. And for iron-3 chloride, you have 1 iron and 3 chlorines, which gives you 162.2. So I'm going to put all this information in my reaction. Okay, so there in my reaction, I have everything I need to start working with. So first, because I'm looking for the limiting reactant, means that I need to work with the 2 reactants, okay? So I have 1 reactant and 2 reactants. In total, I have 2 reactants. So I'm going to work with the information given and the information requested. So take a look. From the information given, I know I have grams. Grams is my information given, but they are asking me about the amount of grams unknown, which means the procedure that I have to do is, so grams to grams has this path from grams given to moles given. To make this procedure, you will need your molar mass of your given. Then, from moles given to moles unknown, you're going to be using the mole ratio. And then, from moles unknown to grams unknown, you're going to be needing the molar mass of the unknown. So this is the path that you are going to follow for this exercise. So we start with the reactants, okay? I have my reactant 1, that is iron-3 oxide. So I begin with my given. The problem gives me 35 grams. Okay, so we have the 35 grams. Remember, here we have the path that we need to follow. I need the molar mass of the given. So I have in 1 mole of iron-3 oxide 159.69. Then I need to multiply times the mole ratio between moles given and the moles unknown. So the mole given is invisible 1. Remember that when you don't see it, even if you don't see it, it's there, okay? So here it's like having an invisible 1 of iron-3 oxide and the moles of the unknown. The unknown is iron-3 chloride. So the ratio is 1 against 2. So where are you going to put it? Here is 1 mole of iron trioxide. Okay, so you're going to multiply times the mole ratio. The mole ratio, that is, there is 1 mole of iron trioxide in 2 moles of iron 3 chloride. Okay, that's the mole ratio, which allows you to eliminate these moles. Okay, now from moles unknown to grams unknown, you need the molar mass of the unknown, which is 162.2. So we say all these times the molar mass of the unknown. In 1 mole of FeCl3 iron 3 chloride, I have 162.20 grams of the same substance. With this, you cancel like that. Okay? And in total, when you perform this in your calculator, so I did the procedure and I got 71.10 grams. That is the first answer that I get, and I need to compare it with the second reactant. Okay, so I work with the second reactant from now. My second reactant is HCl. Okay, and they are giving me 35 grams. So from grams given to moles given, I need to use the molar mass of the given. So grams of HCl I will multiply times the molar mass of hydrochloric acid. So I have 36.45 grams of HCl in 1 mole of HCl. That is L, okay? That's L. Wait. Okay, so then from moles given to moles unknown, I need to use the mole ratio. The mole ratio between HCl and my unknown, okay? So the mole ratio is the coefficient 6 for HCl, that I'm going to write it here because I want to cancel, okay? And the coefficient 2. Okay, this allows me to cancel the moles of HCl with the moles of HCl. And then, from moles unknown to grams unknown, I need to use the molar mass, which is in 1 mole iron 3 chloride, I have 162.20 grams of iron 3 chloride. Okay, this in total, do that in your calculator, and you will get 51.92. 51.92 grams of FeCl3. Okay, with these two answers of the two reactants, I compare. And I will always choose the one that has the least amount, okay? The one that produces less. That in this case is 51.92 grams of iron 3 chloride. This is what we know as the amount that will be theoretically produced, okay? Theoretically, we can produce only 51.92 grams. So the limiting reactant is the reactant HCl, okay? Because that one produces the less amount of product. So once you have your limiting reactant, you continue working with the second question. That is, how many grams of excess reactant remain? Now for that, you need to make a relationship, okay? So what happens for the remain? I'm going to write it here. This relationship is the limiting reactant will also tell you how much excess reactant is going to be used, okay? Now the question is, how many grams of excess reactant remain? So this question is related specifically with the excess reactant, okay? So I need to know how many grams of excess reactant remain, and that tells me that I have also to keep using stoichiometry. So the procedure that comes is the following. So take a look. The excess reactant comes, depends on the limiting reactant, which means that I will be relating limiting reactant with excess reactant. So the procedure is like this. From the limiting reactant, grams given, you will have your excess reactant of grams used in the reaction, okay? This is the relationship that happens in this part. So the limiting reactant is HCl, and the given was 35 grams. So we're going to start from there, okay? 35 grams of HCl. And we're going to follow also the path for grams to grams. And why from grams to grams? Because you have grams given and you need to know the grams used. Okay, so the relationship is grams to grams, which means that you need to keep using the path for grams to grams stoichiometric conversions. So I need to use the molar mass of the given, that is 36.45 grams of HCl that you have in 1 mole of HCl, okay? This allows you to eliminate the grams with the grams. And then it comes the second step. Moles given to moles unknown. You need to use the mole ratio. So the moles given is, the substance given is HCl, and the unknown is Fe2O3, iron 3 oxide, okay? Because you are working only with the reactants, okay? These two relationships is between the reactants. So the mole ratio is 6 for HCl, okay? So I'm going to write it here. 6 moles HCl against 1 mole of Fe2O3, okay? That's your mole ratio, and then it comes the molar mass. For the molar mass is the unknown, so the unknown is Fe2O3. The molar mass is 159.69 grams. That you have inside 1 mole of the same substance, iron 3 oxide. So now you can cancel these moles with these moles, okay? And the moles of HCl also cancel with the mole of HCl. So when you perform this in your calculator, you get 35 times 159.69 divided by 36.45 divided by 6, 25.56 grams of Fe2O3. Now, what does this mean? This means that in the reaction, The reaction used out of the 35, it only used 25 grams. So that's what it means. From the 35 grams provided of F2O3, the reaction only used 25.56 grams. Okay, so that's what it means. So how do you get the excess reactant remain? Because that's what the problem asks you about. Okay, the problem asks you about how many grams remain. Here it is the question. How many grams of excess reactant remain? So for this we need to do this procedure. The remain comes from the subtraction of the excess reactant given, which is 35 grams, and the excess reactant used, that are the 25 grams. So we just perform that subtraction as 35 grams of Fe2O3 minus the 25.56 grams of the same substance. So when you perform that in your calculator, you're gonna have 9.44. Okay, so remain is equal to 9.44 grams of Fe2O3. Okay, so this will be your answer for the part B. And then in the last part, if the percent yield of iron 3 chloride is 92.5%, what is the actual yield in grams? So remember that I gave you a formula. The formula for percentage yield. The formula for percentage yield is the following. Actual divided by theoretical times 100. So, because you are looking for the actual yield means that you need to do an isolation. Now, how do you do this isolation process? Take a look. The theoretical is dividing the actual yield, which means when you move it to the other side of the equation, we'll be doing a multiplication. Okay? So you will have percentage yield times the theoretical equals the actual yield times 100. This 100 is multiplying the actual, which means when you move it to the other side of the equation to get rid of it, it's going to be doing a division, okay? So, percentage yield times the theoretical, all this divided by 100 is going to be equal to your actual yield. Now you just need to substitute by the givens that you already have, and is the percentage yield, that is 92.5%, times the theoretical. Okay, the theoretical is what you got in the question A. If you don't remember, are the 51 grams that we just got. Okay, this is what we got theoretically. So theoretically, we got 51.92 grams of iron 3 chloride, and you will divide by 100. So this is equal to your actual yield, okay? And I got 48. 48.03 grams of FeCl3.